For those who were absent yesterday when I introduced how to solve projectile problems, or those that just need a refresher, I'm going to do a sample problem for you to kind of see how to set the problem up. So in this problem, it says a stone is thrown horizontally from the top of a 78.4 meter high cliff with a speed of 5 meters per second. How long does it take the stone to reach the bottom of the cliff, and how far from the base of the cliff does the stone land? So the first thing is to just kind of try to visualize the problem. So I have a cliff. The cliff is 78.4 meters high. So that's the height. So 78.4 meters high. And it says a stone is thrown horizontally. So it has a horizontal velocity of 5 meters per second. Okay, so the stone isn't thrown upward, it's just thrown completely in the x direction to start. And it's going to travel down in a parabolic path. So to start these problems, you want to create an XY chart. So in the XY chart, there's a couple things that we automatically know. So in the x direction, the acceleration is 0. We always know this, it's a given. We know that gravity is only pulling in the y direction, so that means there's no force in the x direction that's going to cause this thing to speed up or slow down. So in the y direction, we know that gravity is acting on the object, so its acceleration is negative 9.8 meters per second squared. We know initially that this object has an initial velocity of 5 meters per second in the x direction. Okay, initially in the y direction, it's not moving at all. It's not shot up in the air at all. So we know initially the initial velocity is 0. We also know from the problem that we have a height. Okay, it refers to how high the cliff is. So that's our y distance is height. Okay, we don't know how far, that's part B, how far from the base of the cliff does the stone land. So in the x direction, that's an unknown. And then lastly, the thing that we're missing is time. So we're not sure what the time is in the air on either side. So when you set up a projectile problem, the acceleration the x side, the acceleration the y side, and the initial velocity are always going to be known. So those 3 things you can fill in right away, and then the other things you're going to have to get from the problem. But automatically fill those 3 things in first. So now what I'm going to do is I'm going to solve for the time, how long it takes the stone to reach the bottom of the cliff. So I'm going to look at my x and y chart, and I'm going to pick the side that has the most information to start. I'm going to use the y side because it only has 1 unknown, whereas the x side has 2 unknowns. So I'm going to take everything on the y side and I'm going to plug it into an equation. So I'm going to use d is equal to VIT plus 1/2 AT squared. I'm going to plug everything in on my y side. I can't mix and match, so I'm just going to use everything on the y side. My distance is 78.4. I'm going to add a negative because it's falling 78.4 meters. My initial velocity is 0, so this whole term cancels out. And I'm left with 1/2 negative 9.8 t squared. So I'm going to simplify this first. 1/2 times 9.8 is negative 4.9. I'm going to divide both sides by negative 4.9. And I think t squared is equal to 16. And I can square root both sides, so t is equal to 4 seconds. Once I've solved for time, it now becomes a known in my data table. The time is the same on both sides. There are not two different special types of time. So I can automatically put that in. Okay, so the second part of the problem is to figure out how far from the base of the cliff the stone lands. So I'm now solving for the displacement on my x side. Okay, I'm going to use the same equation that I used at the beginning. D is equal to VIT plus 1/2 AT squared. And I'm solving for how far, but now I'm going to plug in everything on my x side. I already used the y side to solve for time, so now I'm going to use the x side to solve for my horizontal distance. I'm looking for this distance here. Okay, so I'm solving for D is equal to VI is 5, T is 4, and then the entire second half of my equation cancels out because my acceleration is 0. So I'm left with my distance, how far from the base of the cliff, is 20 meters.